Here we are, we're at Clintar's yard, and we're about to do the drop test for the SAVE program, and they've been so kind as to give us the use of one of their pieces of equipment to do the drop test. Okay. So now what we're going to do is we're going to measure the width of the conveyor as well as the height. That's very critical. So right now this is coming in at 17.5, so we want to do it between the two guides. And then we want to do the actual salt to the top of the conveyor. Okay, so you don't need to go to the bottom of the conveyor, but you want to go to the top of the flight of the conveyor, because that is the material being pulled through. So that will give us the area of the salt that's going to be coming out. This is our first step in establishing their present level of performance of the material they're putting down. And this will be the first step before anything else is recorded, those dimensions. Our next step is to record the width and the setting that they have on that width. Have the material ready to go, have the truck ready to go, so the RPM should be at the running speed that you expect to see during the applying of the salt. So in this case, we're running with a diesel engine. We're going to have the RPMs roughly around 1500 RPMs, and that way the hydraulics will respond according to the setting of it. So as you can see, the pattern is coming out, and you can see basically where it's dropping. You want to take a look at where the most of this is being dropped. We've just finished doing the spinner test, and what you'll find is there's quite a pattern has developed. And what we're looking at doing is measuring the consistency of this throw. We don't want to do the farthest, and we don't want to do the closest. We're looking for the average spot where it really begins to deteriorate. So that is where we want to measure the width across, and that will establish how wide we're going to be spinning. Here, if you go right over here, yeah. Establish the spots that we're going to be measuring, not the furthest, but about a foot in for the farthest fall. We'll now get the dimension, which comes out on this particular case about 22 feet, and we've recorded the conveyor setting inside, and now we know the width that it's going to be spreading at. We are now going to do the drop test. That means putting our calibrated box underneath the conveyor and time how quickly it fills it up. In this particular case, we are not able to stop the spinner completely. We're going to lift it up out of the way and do the drop test into the calibrated box. If we could stop that 100%, we would just put it underneath there and do the drop test with the spinner in place. So right now we're going to move it up and then do the drop test from there. Let's move this side there. Time test using our drop bar. It comes hinged, and it comes with a hook on both sides, so it makes it easy. Hook it in. When we make it into a square, it is actually 1/10 of a cubic yard. So it's 70 by 70 by 20 centimeters. So we place the box, which is open on the bottom, directly underneath the conveyor, and we're going to fill the box up with salt so it's totally level, and time it to see how long that takes. Okay. What we're trying to do is keep the flow kind of smooth and keeping it around the box so it doesn't keep coming in the area. At the same time, we're timing it. settings here. So in most systems, it'll be from 1 to 9. In this particular system, we're running at 40% of the setting. The gate opening was 3 inches, and it was 17.5 inches wide. The time to fill that was 140 seconds. So you'll need to have the gate height and width to give you the correct setting. This is the cab setting inside. In this particular case, it's 40%. Most controllers have it 1 to 9. The spinner was set at 75%. Same thing here. In most cases, it'd be from 1 to 9 for the setting, and the width was 23 feet. And then you can convert it into meters if you want. This is the general setting. This is the very first setting that you're going to do. Now we're going to find out how close that is to the standards that we had developed through the University of Waterloo. So what we've done here is, before we do any of this, you should fill in all the information about the truck, spreader, and all the information. We're now going to move ahead to the type of, so this is a hydraulic system, and this is going to give you the gate setting that we put in there at 7.62, the gate width, which is 44.2, and that gives you the total area 336.80. And then we'll move over to the spinner. So we're actually putting in the existing settings of this first drop test, and the spinner was at 40%, and the width for 40% is 23 feet, and the width is then calculated in meters at 7.01. We will now move down to the auger, or in this case it's a conveyor, was set at 40%. In some cases you'll see that's either a 4 or a 5. The fill time in this was 140 seconds. We'll move across to the flow rate, which is 0.93 kilograms per second. Now we move across to the chart, where we put into the chart is the speed. This particular parking lot was not a large parking lot, so the maximum speed was 15 kilometers per hour, which we put that in at 15. We're trying to achieve 6 pounds per 1,000 square feet, and we're actually converting it to 2.93 kilograms per 100 square meters. The spinner was set at 40, and we're coming up with a calculation of 3.18. We're very close. We're lower than 5% between what we should be at and what was actually required using this app. So the app made up for doing the calibrations of the equipment. You can have it preloaded and download it on a piece of paper so you know what your time needs to be, or you can have it onto a laptop or onto a tablet or even a phone so that you can see it. Now that we know where we are in our low setting, we're now going to go back and do it on the middle setting and confirm that the time is correct on that. If you come out where you're too high, you will need to either lower the auger inside the cab, the setting on that, or lower the gate. It depends on what your settings are set at to achieve the time and the amount coming out of it.